Okay, so just a reminder, test next Thursday or test number 3. No, that's not right. It's Tuesday, this coming a week from tonight. A week from tonight, it's test number 3. Okay, and I got a review sheet posted for it and everything. There's the formula sheet, you can look at that. And we'll do review on Thursday for it. So Thursday will be review day for the test. But basically, I think it should be fairly, it's the homogeneous stuff. So homogeneous equations, and then undetermined coefficients, variation of parameters, and probably a spring problem, some sort of spring problem. So, but we'll go over that on Thursday, that stuff. So that'll be next Tuesday then. So, okay, any questions, anything? Okay, so yeah, so tonight then we're going to keep on Laplace transforms, what we started last time. So yeah, section 8.1 kind of continued here. It's the Laplace transforms. And we're not going to probably get to differential equations with this until after the test, a few days. So we're just doing transforms for now still. But okay, so let's look at this one here. Kind of leave off one more here. So suppose f of t, let's say it's like a piecewise function here. Say less than 4, okay. Okay, so we have a piecewise function. And if you graph it, right, it looks something like this, like 3t, say like this here. And yeah, so it'd be something like this here then. This goes on forever here. So it's their f of t here then. Like on the y-axis, I guess there. Okay, so so basically here, we'll find the Laplace of this. Let's say find the Laplace of f of t. Like this here. And we did some of these last time too. But basically, just go to definition of it here, right? So, all right, the Laplace of, then bracket here, f of t is equal to, by definition, okay, it's an integral, right? And it's e to the negative st f of t dt. So this is called the Laplace transform here. And notice here, so s is like a constant here. Okay, so you have letter s, and then you integrate with respect to t here on that. Okay, so so how does this go here then? So if you're looking for the Laplace of this one, of say a piecewise function, okay, so this would be equal to, well, basically here you're integrating with respect to t, you're integrating from 0 to infinity. Okay? It's like finding the area under the curve basically when you integrate. Okay, so to do this here, and this is at 4 where it switches here. Okay, so so basically you're finding this area here, right, between 0 and 4, and then you add it to the area under this curve the rest of the way, like that. So it's like two integrals here then, right? You integrate, first of all, you go from 0 to 4, and then on that section, the f of t is given by this, 3t. And then you can integrate then from 4 to infinity. Like this here. Okay, so the Laplace transform then would be given by this. We just got to figure this out here then. And there's a dt on here. I forgot my dt on that. So we got that here then. Okay, so anything there so far? Now the rest of it is kind of slogging through the integrals here. Okay, and some of this is a bit of a mess. So for the first one here, if I kind of break that out a little bit, basically this one, this is an integration by parts deal here. Okay, to do this one, because you have a t here and then a t here, like that. So you can do integration by parts here. So I can take derivatives here on the 3t. So you start doing this, take derivative, that's 3, and then 0. And then this would be, and I take antiderivative with respect to t, that'd be basically, you get e to the negative st over negative s. That'd be 1 there. And then with this one more time, what would be the next one then? That'd be, you get e to negative st over, this go to s squared now, down here, a positive. Because you divide by another negative s there, so it just turns into s squared down there. It's a bit of a slog here in this. So then you can do the bracket here for that. So that would be negative 3t, I was right, over s, e to the negative st. When you multiply these, you get negative there. And this will be a minus as well. Put infinity, or I'm sorry, it's 4 and 0 here. Okay, and then now basically, this is for t values here, right? So then you put in 4 for t and then put in 0 for t. If you put in 4 for t, you get, what do you get? That would be negative 12 there. So negative 12 over s e to the negative 4s. And then put in 4 here for t. That would be minus 3e to the negative 4s over s squared. That's for the upper, anyway. Now, if you put in the lower one, let me check here real quick. Make sure I'm, yeah. So if you put in the lower one here, then now I put in 0. So what would this be here? If I put in 0 for t, 0, right? So you get 0 minus, then put in 0 for t here, you get minus, and then, yeah, it's 0 minus 3 over s squared, like that. Okay. So if you clean up a little bit, you get like negative 12 over s e to negative 4s minus 3 over s squared e to negative 4s plus, and then 3 over s squared. I see this here, like that. That's that part. Okay, and then back up here, then the other part was this. Okay, and that one's a little bit easier. I can just go to bracket here, and that would be, it'd be 2 over negative s e to negative st, infinity and 4. Now, if you put an infinity here, okay, for this, what does this go to here? So let t be infinity. We're assuming here s is greater than 0. Okay, so if you assume here that s is greater than 0, put t infinity, this goes to 0 here, right? That if I put infinity, x goes to 0. Because you get like basically e to negative infinity then, which is 0 basically there. Okay, so that's 0. And then on the other one, so minus, then the lower one, put in 4, I get 2 over negative s e to the negative 4s, like that. So then that's going to be what? You get 2 over s e to the negative 4s, like that. Okay, so anything there on that part? So we put this together with the other one. It looks like you get here. Now there's actually some like terms here. If you look at these two, so you get like negative 10 over s e to negative 4s. I don't like the s's because they look like 5s, but so it's negative 10 over s e to the negative 4s minus 3 over s squared e to negative 4s plus 3 over s squared. Then finally, that would be the answer here then. Okay, this would be the answer for the whole thing. So that'd be the Laplace transform of the original one there. With that, okay, that piecewise function. So you can find the Laplace transform of a piecewise function even there like that. So, okay. There's the whole thing of it in one screen there, I guess, but okay, any questions in that one going through it? So basically it's just a little bit of a slog, right? You have your definition. This is a definition here, Laplace transform. And then it goes to this here then for this one. So you integrate from 0 to 4, and then integrate from 4 to infinity. And then go through the integrals there. So anything on that one? Okay. Next up then is section 8.2. Talks about inverse Laplace transforms. So, and eventually we'll connect this to differential equations at some point, but that's not today, but in a couple classes. So 8.2, inverse Laplace transforms. This is like the backwards problem here, basically. So things to recall here. There's also, on the computer, is also a table. I should have printed out a table for this, which I didn't, but I'm just going to write some of them down here. So from last time, I'll just write these things down. The Laplace of 1 was equal to 1 over s. Okay, so this is going to be like a little table here. The Laplace of t to the n. Okay, it was this. It's n factorial over s to the n plus 1. These are some ones we did these last time. Went through some of these. The Laplace of e to the at is equal to 1 over s minus a. There's like 6 of them here. I'm going to write down. The Laplace of cosine at. So cosine at here, all right, one more time, is equal to, that's s over s squared plus a squared. Okay, and then the Laplace of sine of at, I'll just write them down here, equals that's a over s squared plus a squared. It's an a here. And then finally, one more. The Laplace of e to the, I'll just write it down here, e to the at f of t equals, you can write it like this here, capital F of s minus a. Now, by the way, here, this capital F, I'll talk about here in a second, but you might want to copy these down, you know, if you're taking notes on it. But so you want to make sure, because I'm going to refer to these a bunch tonight here. Okay, so we'll refer to a bunch of those tonight. So actually, I'm going to take this and copy it. So maybe, okay, for reference later here. But this capital F here, that's just another way of saying the Laplace, right? The Laplace transform. So if I go back up here real quick, just real quick here. This is also here. You have to write this down. This is also called f of s, capital F of s here. So it's just another notation for Laplace transform. But okay, if we get back here then. I'll give them the copy here because I'm going to refer to these a bunch tonight. So. Okay, anything there so far? Now, basically tonight we're going backwards, right? I'm going to give you. I'll start with an example here for inverse Laplace transforms. Let's say we'll find this now. Start off here. Let's say we have capital F of S is equal to 1 over S minus, say, 8. So let's say this is the Laplace transform here. Okay, and we want to find then the inverse Laplace. We want to find this now. That's almost like derivatives and antiderivatives, kind of same idea. Okay, so looking backwards here. Okay, what do you think here? If this is the Laplace transform, right, function of S here, what would be the F of t? And here's your things to look at up here. So you try to match it up with something here. Right, it's this one right here, right? Yeah, so the A is 8, right? So all this is, right, if this is the Laplace transform, then the original function was this one here. It was e to the 8t. And that's your answer. That's all there is to that. Right, so this is like this, and then you read it backwards. Okay, so that's that. So this is the Laplace, and this is the inverse Laplace, or the original function here. Anything on that? Okay. Okay, so we got that here. Let's try this one here now. Let's say F of S is equal to, let's say, 7 over S to the 4th. So we're trying to figure out the F of t here. Well, it vaguely looks like what? It looks like vaguely this one up here. Okay, so, but that 7's kind of in the way there. So you got to fix it up here a little bit. So I can bring the 7 out front. You bring the 7 out front here like this. And now this is like what? 1 over S to the 4th. Okay, it'd be nice if this were what number up here? If this is, if I'm kind of make it look like this. I think, yeah. It'd be nice if that were 3, right? Because the 3 plus 1 would be the 4 then, right? The 4. If it'd be nice if the n were 3, that'd be nice, right? So it'd be nice if there were 3 up here. Okay, so we can do that. You got to multiply here by 3 over 3, like this here. So then if we rearrange this a bit, so then you get, right, this is equal to, that'd be 7 over 3 times 3 over S to the 4th. Actually, I want to have, wait. Hold on here. I want to have, I said that wrong. It'd be nice if it were, I want 3 factorial. My bad. I want 3 factorial here. It'd be nice if that were 3 factorial. Right. So yeah, it'd be nice if this were a 3 factorial. If this were a 3 factorial, that's what we wanted there. Okay. So then this is equal to what then? Well, now this part here, then this can just come down. That'd be 7 over 6. And then now what would this be here then? So if you take the inverse Laplace of this, then look back at these things back up here. So this guy right here looks like, if you go back up here, that'd be what? T to the 4th, right? Because the n here is 3, right? So, or I'm sorry, it'd be t to the 3rd, right? Because the n's 3 there. So that would be t to the 3rd. So that's the F of t. This is capital F of S. This is little f of t here. Right, so it'd be like that. That'd be the inverse then. Okay, anything there? I should also maybe mention, too, we had a couple other rules. We talked about these last time, but I think it's worth mentioning maybe. A couple other rules here, right? I'll just write this down. You don't have to write this down, but the Laplace of, say, a times f of t, like this, if you have a constant there, okay, like the Laplace of a constant times a function, it's a linear transformation. So you can take the a out. So there's also this here, right? If you have a constant times a function, you take the a out. That's kind of what we're doing here. We took out we took this part out in front here. Okay, and then also the Laplace of f of t plus g of t, right? You can do this term by term here because it's a linear transformation. Laplace of g of t. We talked about this last time. You don't have to even write it down or anything, but it's a linear transformation. So if you have the Laplace of a sum, it's the sum of the Laplaces. And then if you have a constant times a function, you take the constant, just take the constant out there. So those are a couple ones there. And we actually use those down here then for the inverses in a little bit. Okay, so if we take the Laplace of this, or if we take the Laplace, the answer would be this up here then. So, okay, anything on that one? Okay, let me try this one here now. Let's say capital F of S is equal to, let's say, S minus 3 over S squared plus 16. So I'll try this one now. Let me see if I can bring back the functions here. Just for reference. Maybe I'll try again so you can read them here. I don't know. Let's see. There they are. Okay. I'll tell you what, this pen's so nice because in the old days, you have to write that in the board, someplace in the board somewhere. But it's just nice to be able to have them all right here. But anyway, so which ones are we going to be using here, do you think? Looking at this, which ones kind of seem reasonable to be involved here? Looking for the inverse Laplace. Yeah, maybe this one here, and might both these be involved somehow here on this one, right? Like that, because they have the s squared plus a squared thing there. Okay, so basically here you could break it apart and break it into two fractions. I see, break it like this. Okay, now the first one's pretty good to go because what would be the a? The a would be like a 4 there. I guess so. I'm just going to recopy that though for now. But we actually have to fix up the second one a bit because this one looks a lot like that one. So that one's pretty good to go. Now listen over here though. Got to watch out on this one. There is a 3 here. Let me bring that 3 in front, right like this. Okay, so I got this. Now, in order to make this one work here, what do I have to have up here? If I'm going to be using this one now for the other part without the S in it, right? So what numbers should this have to be up here then? Looking at this, it have to be a 4, right? But I have a 1 there. So what you can do here, you multiply by 4 like this, because you have to get a 4 up here. It's a little tricky thing there, right? With this one, you got to get a 4 up there. So then if we rearrange that, this is S over S squared plus 16 minus, and then that would be, I could say 3/4 times, that'd be 4, right? 4 over S squared plus 16. Okay, and now it's pretty much ready to go here. So what would be, so I'll do little f of t now here. So this is capital F of S. Those are all capital F of S's there. Now I'll go over to little f of t. This is where we do the inverse. Okay, so what would be the first one there? So this one here. Right, cosine 4t from this one, right? So it's cosine 4t minus 3/4 times, and then the other one over here, that would be what? Yeah, sine 4t, right? From this one, that's this. So the a is 4 here, right? So that'd be sine 4t for that one. And that's the answer there then. Okay, so anything on that one? They're not bad once you get used to them, but it take a little bit of getting used to, I think. Anything on that? Let's try another one here. So I'm going to find inverse Laplace of this one. He's back here for reference. Okay, so which one? So what do you think here? Is there one that vaguely look familiar? Yeah, e to the at kind of looks vaguely right, but it's off a little bit. But we've tried to fix it up here. For one thing, there's no 7 in front of here. It's just an s minus a. So what you could do here, right, if you kind of do some factoring here, maybe some kind of clever factoring like this. I see a factor like that here. Okay, so then this is what? Capital F of S equals, then that would be, okay, so then I could say here, right, I could say 2/7 times 1 over S minus 1/7, like that. Yes, now we got it basically here, right? We can go for this now here. So, right, so I could say what? Little f of t here now would be equal to 2/7 comes down. And what about this guy right here then? How would that work out? Yeah, e to the 1/7 t, right? So yeah, so that'd be e to the 1/7 t, like that. Because the a is 1/7 there, right? I should have did this. What if this were a plus? If this were a plus instead? Yeah, if it were a plus there, actually, I'm going to change this problem just slightly. It's an easy change. I meant to do this. Let's make this 7s plus 1. I'm just going to change the problem here just to show this 7s plus 1. So now what? This is s plus 1/7, and this is plus 1/7. Okay, and then if you had this here, then how would that go? How would it finish up down here? Well, you can think of as s minus negative 1/7. Think like double negative here, right? So how would this go down to here then? It'd be a negative 1/7, right? So this would be like a negative 1/7 here. Okay, right. So then that'd be the answer here. That'd be the inverse. That'd be inverse Laplace for this one. Okay. Good. Okay. Anything on that one? Okay. They get a little harder as they go here, but I mean those aren't too bad. Or yeah, that's basically it. We're getting the pieces of it here. They're not bad though. Okay. Next up, we got through those basic kind of ones there. Let's try this here now. Okay, so we'll try this one. Okay, and I'll put this down for reference here in a minute, but well, this doesn't quite look like any of them, right? Because we got this kind of messy fraction here. You have to do partial fractions. Okay, so in this one, I don't remember partial fractions ever from Calc 2 at some point, sometime back in history. But basically here in this one, first thing here, right, we've got to try to break it apart in simpler fractions. Yeah, first thing I got to do here, right? So you got to do partial fractions on this one. So, right. So for this one here, I got to do partial fractions. You got to get simpler denominators here for this. So you got to start by factoring this, right? So that would be like s. It's s plus 5, s minus 4, like this. Okay, and right, and then over here it goes like this. You have an a over s plus 5 plus b over s minus 4. Okay, so if you have like non-repeated linear factors, so if you have non-repeated factors and they're linear, it's just you have a and a b like this. Oops. So this is kind of the form of it here. And then you have to figure out the a and the b are in this. Okay. Different ways you could do this. I'm going to show you one way to do it and then kind of a shortcut way. But what you could do here, if you multiply through by the LCD, so you want to clear out the fractions here, right? So if you multiply through by this, multiply both sides by this, both sides, basically then, so if you clear the fractions, right, you could say this, I get negative 3s minus 24 is equal to a times, and then that would be s minus 4, because the s plus 5s would cancel, plus b times s plus 5. I'll say here, so clearing fractions, I'll say, basically multiply both sides by this, and it cleans out the fractions, and you end up with this here. Now what you can do then to get the a and the b, okay, you could pick convenient x's, or I'm sorry, pick convenient s's. Okay, so this one we do it. Pick convenient. Well, I can't spell convenient, but whatever the word is, pick convene. I never can spell this word. Convene. Something like that. Pick convenient x's or s's. So for example, I'm trying to find the a and the b here. And it should work for any value of s you pick, okay, if you did this right here. So a nice value of x, a nice value would be 4, for example, because if I put in 4 for s, what happens if I pick 4 here? Say s, so I'll say here, say s equals 4. Okay, what happens here then? So I get over here, I get like negative 36 equals, and then now here it will go away because this will be 0. Negative 36 equals, and that would be 9b. All right, so you get b equals negative 4. Okay. Now, what would be another convenient value to pick? Negative 5, right? So you pick negative 5, you get what there? So that gives you like 15 minus 24 is it negative 9 or negative 11? 15 minus 20, negative 9. Okay. So negative 9 equals, and that goes way over here. So then you get what? Negative 9a, like this, because you put negative 5 here, negative 5 here. It zaps out over here. That goes away. So then you get a equals 1. Right, so a is 1 and b is negative 4. Okay. So basically here, yeah, so that we got, well, actually, I want to come back here and show you something then. at some point here. So negative, I'll just fill this out for now. I'll come back and show you something else. So we got here that negative 3s minus 24 over s squared plus s minus 20 is equal to, that would be a, which is 1, so 1 over s plus 5, plus, and then negative 4 over s minus 4. Right, so you can end up writing it like this here then. Okay, so then, so that's our, remember, that's our f of s then. I'm going to finish this problem up, and I'll show you another way to do it. It's a little bit easier too. Okay, so now that's our capital F of s, right? So we got f of s is equal to 1 over s plus 5 plus negative 4 over s minus 4. So then this is equal to, now these here then, 1 over s plus 5. Oh, s's are so bad at this. I wish it wasn't s's. So s plus 5. Then minus, I could say 4 times 1 over s minus 4. So then from this, now we'll get the function. And if I recall, this one would be what? This is from the list, I think this is e to the, and there's a sign switch. So e to the negative 5t is that one. Minus 4, and this would be 4, and this would be e to the 4t here, like that. That's back from the table from the Laplaces there, inverse Laplaces. Okay, so there's the whole thing, right? So we're looking for, here's the whole thing of it. Okay, any questions there on that? So basically we had our f of s right here, and then these partial fractions, you can break it apart into this, right? So this one here, you could rewrite like this instead. Okay, and then you do the use the table that we had there, and you get this and this for those two. Okay, anything there? Now, there's actually another way here I want to show you for picking the A, for finding the A and the B. There's actually a kind of neat way to do this, a little bit quicker. Okay, so you don't have to write this down, but they talk about it in the book some. But if you have like distinct linear factors here, because there's a quick way to do this part. Okay, so it's called the cover-up method. You can use what's called the cover-up method here. Okay, to get the A and the B. And basically, for the s plus 5 factor, okay, if you're trying to find the A, okay, all you got to do here to find the A, you look over here, you kind of erase out the s plus 5 here, okay, and put in negative 5 for the rest of it. Okay, so if I want to find the A, right, so just pay attention to this part. If I want to find the A here, what you could do, okay, right, the A has the s plus 5 under it. You come over here, kind of erase out the s plus 5, okay, and plug in negative 5 into the rest. So, right, so I could say A is equal to here, I put in negative 5 into the rest of this now, into this part right here, put in negative 5. Okay, so what, that'd be what we got before. You get like 15 minus 24 is negative 9. Okay, so you get negative 9 over, and then you put in, again, we're putting negative 5 into this. And then the bottom, you get what, negative 9? So A is equal to 1, just like we got before. Okay, and then for the B, you do the same thing. So for the s minus 4, come over here, you ignore the s minus 4 over here, and then you put in 4 into the rest of it. So you put 4 in here then. So over here then for the B, ignore the s minus 4, and then put 4 into the rest. Because that gives you like what, negative 36 over 9? Okay, and that gives you negative 4 there for that. So you get the A and the B like that very quickly. And it only works if you have like these distinct linear factors, right? If you have distinct linear factors like this, that's when it works. If you have quadratic factors, it doesn't work so well. If you have distinct linear, okay, then it works. So, Okay. So, but I could have saved. So basically, I could have saved like these lines here. You don't have. You can save those. You don't have to do those. Replace it with this instead over here. Okay. So anything on that one? Okay. That's number 5. They're out of order here. On to my number 6 somewhere. Yeah. Okay. On to the next one. We'll get through maybe a couple more tonight. I don't know. Yeah. Okay. Let's try this one next. This might do it. So number 6 here then. Let's try this one now. So we got. So see, I have this one here. I want to find the inverse Laplace of this one. This is another partial fractions thing again, right? You got to kind of break it apart here. Get the partial fractions. This part down here kind of looks like something maybe, but we'll come back to that. So anyway, here, let's work on this one a bit. So gotta get use partial fractions here. This one here, it goes like this. If you have repeated linear, it looks like this here. You have a over s minus 4 plus b over s minus 4 squared plus c over s minus 4 cubed. You have to have the powers going up when you break it apart. Because it looks like this here. You can see like that. Okay, and now we gotta find the A, B, and C. The cover-up method doesn't work here because they're repeated. Okay, so you multiply through, so you clear out the fractions. So clear fractions, you multiply through by this one. Okay, so you get negative s squared plus 4s plus 6 equals, that'd be a times s minus 4 squared. Is that right? Yeah, okay. Plus b times s minus 4 plus c. So you end up with this here. Okay, is there anything there on that so far? Okay. Now I'm going to try something here. Okay, another way to do this now, well, it's kind of like when we did the undetermined coefficients with the earlier. Okay, you kind of match up your powers here. Okay, we're trying to find the A, B, and C. Okay, you could try to pick convenient S. You could pick convenient S's. That'd be one approach. You could try to pick convenient S's and get it that way. Okay, I guess 4 would be pretty good. That give you the C right away if you pick 4. But I want to show you something else though. Another way to do this. Basically, we'll compare coefficients like powers. Okay, and maybe just kind of watch this here, right? So if I were to multiply all this out here, if I multiply all this out, I'll get s squareds, I'll get s's, and I'll get constants. Those kinds of terms. If I multiply all that out, if I start with the s squareds, compare coefficients on both sides. Okay, if I look at on the left side, what's the coefficient on s squared on the left side? It'd be -1, right? What is on the right side? Imagine if you multiply it out, or if you multiply it all out. You don't actually have to multiply it out, but imagine what it would be if you multiplied it out. What would be the coefficient in s squared? On the s squared, it would just be the a, would it? Right, because just a, because if you multiply it out, you'll get as squared, and that's the only place you'll get the s squared would be from, right? If you have s minus 4, right? You multiply it there, you get like s squared plus some other stuff. Okay, and then you got like an a through it, so you get like an as squared then, right? So that's what you get, as squared, but you don't get any. That's the only s squared term you get would be that first one, right? You won't get any other s squared terms. Does that make sense? If you're to multiply it out, so you get -1 equals A. Is that right? I think it's like that. So you just get negative 1 equals A. That's it. So negative 1's A. Just by comparing the s squareds. Okay, now let's go to the s's. This one's a little harder for me. What about on the left side's easy? What's the coefficient on the left? 4. Now, I don't know. If you multiply all this out here, okay, where are you going to get s terms? You're going to get this here. You'll get like a negative 8s at some point when you FOIL that, right? Because you do your s minus 4, you start FOILing, you'll get like a negative 4s, another negative 4s. So you'll get a negative 8s there. And they're going to take an a, multiply through it all, right? So you'll get like negative 8as from this. Okay, if you're going to multiply it out. Does that make sense? And then now, so there's going to be a negative 8as from this, or negative 8a from this. Any other s's are going to be formed here. What about over here? You're going to get a bs, right, when you multiply that out. So it's just the coefficient there be a b. See it like this then? Okay, so that'd be for the s's then. Anything on that? Does that seem? Now if you look at the constants, okay, what's on the left? 6. And now look at the right side. What would happen here? You multiply this out. What kind of constant would you get there? You would get you get 16, and then you take the a through it at the end. 16a. You get constant there. Any other constants? Yeah, and there's also going to be a negative 4b here, right? So a negative 4b, and then also the c, right? So that's how those would match up. Now you could multiply it out. If you don't like that, you can multiply it out more and see it, but you can save yourself a little bit of labor there if you just do that. Anything there so far? Okay, so then you can get the a, b, and c here, right? So the a is equal to negative 1, and then the b, it kind of works down here then, right? The b would be, that's what, 8. I think b would be negative 4 then, right? Because the a is negative 1, you get 8 here. Subtract the 8 over. So you get like b equal negative 4. And then here then, I got to work on this one. That's 6 equals, that'd be negative 16 minus, I think, plus 16 plus c. I think it's 6 equals c, or c equals 6 there. Okay, so anything on that there? So then what? We got capital F of s is equal to, that would be then a, which is negative 1. So negative 1 over s minus 4 plus b, which is negative 4 over s minus 4 squared plus c, which is 6 over s minus 4 cubed, right? So you get this here. Okay, so anything there so far in that? Okay, now we almost got it. So there's our f of s. Let me zoom in here a bit. So look at that. And let me get my theorems back here. Let me get the table back, if I can get that somewhere here. Just for reference again. So I'm going to start looking at these. Okay. What's going on here? Okay, let's look at the first one here. The first one's pretty easy, right? That's just going to be this one. And that's here. Okay. Now the second one, third one here, he's a little trickier. It's actually related to this down here then, for these last two. Okay. Let me rewrite here a little bit. I gotta rewrite this a bit here. See if I can make this make sense. Okay, that's just the E one. That's an easy one. And this one, we'll get that 4 out of there. Minus 4. And then it would be like that. I'm kind of fixing this up here a little bit. I'll show you how it goes here then. Okay. Now the second and third, we'll come back to that one in a minute. Okay, the first one's easy, an easier one here. The second one here, basically what this is, right? Imagine the -4 weren't there, right? It kind of looks like we're looking at this one down here basically now. So I think the way to think of this now, imagine the -4 weren't here. Okay, which one would you be using if the -4 weren't there? Which one would you want to use? If that -4 weren't there, which one of those up here would kind of look kind of right? Yeah, this guy up here. Okay, right, that can look right there. That -4 right there. And I want this to be a what up here? I don't want that to be if that weren't there, this would have to be a 1 factorial. That's actually just right there, right? So yeah, so I'm going to rewrite here just a bit. That's like 1 factorial there over s minus 4 squared. Plus, and then over here, I get that 6 times. And then again here, I'd be using the same rule again. But what would I want, if that -4 weren't there, that -4, what would I be using? What would I want up here then? I'd want a 2 factorial. Yeah, or 2, right? So, yeah, so I could fix it up like this. Like that. You notice here, I put a 2 factorial down here as well. So it's like by 1 there, really. Okay, so we got that. Okay, anything there so far? Now we can come back and actually get these. Okay, the first one now, that's the easiest one. That's -1. That'd be e to the 4t. Okay, that's by this rule here. Okay. Now the second one here, this is tricky because it uses this thing down here. Basically, pretend basically, I'm going to leave a little space here. I'm going to be using this thing here now, actually. Pretend the -4 is not there. Okay, and that would be what then? That would be, if that -4 weren't there, that'd be t to the first. Right? If that -4 weren't there, that'd just be a t to the first here, like that, by using this one. Okay, but what that -4 does there, that sticks an e to the at in front. Okay, so if that -4 weren't there, it'd be t, but now instead it's going to be this. There's an e to the 4t in front. That's that shifting theorem here. That's using this one right here. Okay, like the a here in this, right? The a is like the 4. Okay, and that goes out front here then with the e. So you pretend it's not there. If it weren't there, it'd just be a t. Okay, but because it's shifted by 4, we have s minus 4 there instead. You put that e to the 4t in front. Because that's that one. Any questions in that one, in that part? That gets tricky to me. Okay, plus, now then this is what, 6 over 2, which is 3, I guess. So 3. Now you do the same thing here. Pretend that's not here. And that would be what? If that weren't there, that'd be t squared. Right, using this one. Right, it would be, I'll go a little space there. It would be t squared normally, right? But again, there we took the s replaced with s minus 4. Okay, so that's going to be out in front here. Again, that's e to the 4t here, like that. And then this is your answer. This is the answer here then. Okay, so any questions in that one? Okay. I guess we'll leave it there for tonight. I'm pushing it to get through another one. The problems only get bigger for a little bit here. So, and that'll be good. We'll do another one of those another time. But it kind of, you got the idea of it there maybe a little bit. So you should be able to do some of those now. But really, yeah. No, this table, no. There's bigger tables. Actually, if you look on the computer on my Open Math, they have a bigger table there. I have a link to a bigger table. Right, but that's right. It's not comprehensive. This is a very limited table here. And when it comes to test time, I'll give you a bigger table you can use. It'll be a little bit bigger, but okay. So anything on that one? Let's see. Okay, so yeah, on Thursday then, I'll go ahead and stop there for tonight. Or I'll go back here. But on Thursday, we'll be doing review on Thursday then. Okay, so it'll just be review on Thursday for the test. So and the test will be Tuesday. And then, yeah, we'll go from there. So.